Welcome back to the ICND1 video series. In this video we'll be talking about the different network topologies and how they work. So let's start off with the star topology. In the star topology, devices connect back to a centralized point known as a hub. So by devices, I mean our computers, our laptops, our printers, our servers. Devices that we use that make up our network connect back to a centralized point known as a hub. And the way it works is that when devices want to communicate, the data that they send between each other will flow through this centralized device, and this device is tasked with forwarding that data onto the correct destination device. Now this centralized device is normally a switch or a hub. Before switch came out, it was a hub, but one of the massive security risks with a hub is that a hub offers shared bandwidth in which only one device can send at a single time, and with a hub, all data, all packets were forwarded out every single port, which obviously poses a massive security risk. So in modern networks, a switch is used as the centralized device. And so with a star topology, there are a lot of connections because we have to have a cable running from our end device, from our client, from our PC, from our server, from our printer, from our phone, to the centralized device. But with a star topology, if one cable fails, that means that only that device on the other end of that cable has lost network connectivity. These devices will still be able to communicate with each other and will still have network connectivity. One of the drawbacks still of a star topology is that if this device fails over here, then the network connectivity is lost for every device that uses this centralized device to connect to the local area network. With the star topology, let me see. Yes, we talked to so with a star topology, it's also very scalable. So we can add more switches together, allowing us to scale our network in that we can have multiple devices connected together by using a few centralized points, which is known as a tree topology. So with a mesh topology is when we can have redundant connections between our devices for redundancy. Now normally, we'd have redundant connections between our two most important devices, our switches and our routers. So when we go to the actual network architecture, how we should build our network, Cisco always says that with local area networks, we should have devices known as access devices. These devices allow us to connect our end users to our networks. Cisco also says that we should have switches that forward data between these access devices. This is known as the distribution layer. So you can think of as devices connect to our network through these access devices, and whenever devices from this switch want to communicate with devices on this switch, they would have to go through these distribution layer devices, these switches, in order to do so. Now, if we just had single connections, this is not a connection by the way, if we have single connections running between, this poses a problem because this represents a single point of failure. If this cable goes down, then essentially devices that connect to this switch have lost complete network connectivity. They'll still be able to communicate locally, but they won't be able to access any other resources. So Cisco says an easier way to solve this issue is just to run redundant connections between our devices, which means that if one device or if one cable fails, we still have network connectivity. This is known as a partial mesh because not every single device has a connection to every other device. As an example, switch 1 connects to switch 2, switch 3 and switch 4. But switch 4 on the other hand connects to switch 1 and switch 2. It doesn't have a connection to switch 3, which means it doesn't connect to every other device. The good thing about partial mesh is that they're not as expensive as a full mesh topology, but they're not as redundant as full mesh topologies. Now with a full mesh topology, it means that we have a redundant connection between every other device or every other site. Full mesh topologies are normally used for WAN connectivity. So imagine these are our different sites across the world. We could have a connection from one site running between each and every site, which means that if devices in site 1 want to communicate with devices in site 2, they can use this connection, they can use this connection, they can use this connection, and they can use this connection. So there's 4 different ways devices inside one can communicate with devices inside 2, which is very redundant. It means that there's very small chance of a complete network outage, or of devices losing network connectivity. The problem is it's very expensive, and it's only used when we're going to have a lot of data running between our sites. So as an example, if we know that these sites are all going to be sending loads of data, loads of information between each other, then a full mesh is feasible. We're able to say, like, we can have a full mesh because we're going to have loads of data running between our sites, so it's feasible. However, with a partial mesh topology, if we have a few sites, and let's say that this site over here, site 1, site 2, site 3 and site 4. Site 1 is a very small site, and not much communication is going to be occurring between site 1 and the rest of the other sites. What we could do, we could have a full mesh between site 1, site 3 and site 4, because loads of data is going to be flowing between those sites. But with site 1 we can have a single connection, because if site 1 goes down, then it doesn't really matter, because it won't really affect our network connectivity and our business in a big way. With the hub and spoke topology, we have one centralized site known as the hub, and we have multiple remote sites known as spokes. This is normally used for wide area connectivity. The way it works, every spoke site has a connection back to the hub site. So now whenever any data has to flow between spoke sites, that data has to flow through the hub site first. This is very cost effective because we can have connectivity between our sites with very few connections. The problem is we can experience what's called a bottleneck at the hub site, in which so much data is flowing through the hub that it can't process the data fast enough and forward it fast enough. And so what happens is that our network starts to slow down. There's too much traffic on our network, and data flows between our spoke sites very slowly. We would mainly use this kind of network topology when our spoke sites, when there's going to be limited traffic running between our spoke sites, and most of the traffic will be running from our branch sites to our hub site. So a hybrid topology, all that is just a combination of all the other topologies I've talked about to build a complete network. So as an example, within our local area network, we'd have a star topology in which we have multiple devices connecting back to centralized devices, allowing for multiple devices to connect together with limited cabling and connectivity. We'd have a partial mesh, in which with Cisco's 3-layer architecture, we have access devices which allow devices to actually access the network. We have a distribution layer, which all that does is forward traffic between our access devices. So forward traffic, and the reason why we do this is because it's very, very scalable. When I go and talk about the different architectures that Cisco offer, that Cisco want us to follow to build our networks from, you'll see how it can be scalable. And so this is a partial mesh design, because as you can see, the distribution switches have got a connection to all the access layer switches, but the access layer switches don't have connectivity between each other, and only have connectivity between the distribution layer switches. Now when we want to get off our network and onto some other network, we normally be accessing the internet, or in this case, if this is a business, the other sites that we have across the world. And to access those sites, we can use a hub and spoke topology. We can even use some sort of full mesh topology, or we can use a partial mesh topology. And so with a full mesh topology, we have redundant connections running between our sites, and this is normally used if we know we're going to have a lot of traffic and data running between those sites. So if a loss of connectivity even with one of those sites is going to prove a massive hit in our business and in our sales. Hub and spoke and partial mesh are normally used when we have data running between, when we don't have much traffic running between certain sites. So in this case, there won't be much traffic running between these sites, which means that if one of these sites loses connectivity, it wouldn't really make much of a difference to our business. Or if we have to go through a hub which is a lot slower, then it wouldn't really affect our business, because all of our traffic will be flowing to the main site. These devices here would have to have access to resources at the main site, and wouldn't really need access to resources at the remote branch offices sites. And so with a partial mesh is exactly the same thing. Maybe this is a small network, and if this guy goes down, it doesn't really matter, because our networks, our business is still able to function with these sites. It was these three sites which were forwarding most of the traffic, which were really important to our business needs. This site was only important, was only useful as long as you had a connection back to the hub site. So as soon as you lose the hub site connectivity, then that's it. So in this video, we've looked at the different network topologies, we've looked at how they work, we've seen how star and partial mesh are mainly used in LAN, local area networks, and a hub and spoke and full mesh are used in wide area networks. I hope this has been informative for you, and I would like to thank you for viewing.